Hi, my name is Ethan Dahmus, and this is my submission for the Makeup Lab 8. Here's my documentation that I am able to do this with no 30% penalty. And for exercise 1, here's my demonstration of the comparator. As you can see, once the input goes below 2.5, it turns off, and once it's above, it turns on. Next, here is my analysis for the gain of the given circuit. And here is my processing for the unity gain op amp. As you can see, when the voltage is below about 1.8, it doesn't accurately follow the input voltage, which is because of a limitation of the op amp we're using, where it needs about 1.8 volts for the transistors to turn on. Here's my inverting circuit. As you can see, when Vin decreases by a little bit, Vout increases by 10 times more, and vice versa. The Vout is constrained between 1.8 volts and about 4.2. I think this is because of limits in the hardware. Here's my demonstration of my integrating circuit. As you can see, when Vin is 0, Vout is about 4.4. And when you make changes to Vn, it's a similar effect on the Vout, but it slowly goes back to that value. And then when you cross above 2.5, it rapidly drops to about 1.8 volts, and then nothing affects it. And this pretty much lines up with the theory. When I solved the circuit, I found that VO basically scaled with the integral of Vn. So that kind of follows that behavior. All right, here's my code for the Arduino. It's pretty simple. I just define the pins, read the values of those pins, and then send those values over the serial monitor. For the processing, define some values, open up the port, parse the strings, and put those into variables, and then map those variables from 0 to 10, 23, 0 to 5. Then I draw those on the plot. And if it's x is greater than the width, it wraps back around. I have a function to draw the grid. I'm basically just drawing all these lines that you see here. And then the legend as well, where I'm drawing this thing in the top right. It's just some text and some values.